Good afternoon, dear students. So we can go through our next module, that is chemical bonding 2. In the previous module we were discussing about the covalent bonds, isn't it? Covalent bonds and the rules regarding the formation of a covalent bond and the molecular orbital diagram, etc. Okay. So in this chapter we will be dealing with the ionic bonds. Ionic bonds. As you know how these ionic bonds are formed, they are formed by the transfer of electrons, isn't it? Covalent bond formed by the sharing of electrons, while ionic bond, it is formed by the transfer of electron from one atom to another. A typical example for an ionic compound, that is sodium chloride, isn't it? NaCl, sodium chloride. This is an example for an ionic compound. And also regarding the electronic configuration, sodium, it has got atomic number 11, isn't it? So the electronic configuration will be 1s2, 2s2, 2p6, then 3s1, isn't it? 2, 4, 10, 11. Okay, sodium, atomic number 11. Then in the case of chlorine atom, the atomic number, it is 17, isn't it? So 1s2, 2s2, 2p6, 3s2, then 3p, how much? 2, 4, 10, 12. So the remaining, it will be 17 minus 12, that is 3p5, isn't it? 3p5 configuration. So here you can see this for sodium atom, it requires one more electron in order to attain a stable octet configuration, isn't it? It requires one more electron so that it becomes 3s2, isn't it? Here this chlorine atom, either it can donate this one electron or it can gain one electron. Two possibilities are there for sodium atom to have a stable configuration. It can accommodate one electron, that means it can gain one electron, or it can lose one electron, isn't it? Two chances are there for sodium in order to attain an octet configuration. And also see here in the case of chlorine atom, see what about the valence shell configuration? 3s2, 3p5, isn't it? The total the electrons in the valence shell, that is 7, isn't it? That means it, in order to gain a stable octet configuration, it requires one more electron. It can gain one electron to attain a stable octet. Stable octet configuration means 8, isn't it? Outermost shell, it should contain 8 electrons. So here it can gain one electron or it can lose this 7 electrons, isn't it? By losing the 7 electrons, it will be having a stable octet. So two possibilities are there for both of them, for sodium as well as for chlorine. Here in the case of chlorine atom, it is easy for the chlorine atom to lose one electron than gaining one electron. Okay, so sodium, it will be losing one electron. Sodium will be losing one electron. That is the in order to attain the octet configuration, it will be losing one electron to form Na plus. That means it is losing one electron, thereby it will be having a positive charge. Then regarding the chlorine atom, see, two chances are there. Either it can gain one electron or it can lose 7 electrons. See, losing 7 electrons is a difficult task, isn't it? So it is more easy for chlorine atom to gain one electron. So this chlorine, by gaining one electron, it becomes Cl negative, isn't it? By the addition of one electron, it will be having a negative charge. So here what happens is that this sodium atom, it will be losing one electron. That means it is electropositive in nature. Sodium atom is electropositive, and also here chlorine, it is electronegative. So sodium is electropositive and chlorine is electronegative. So by losing one electron, what about the electronic configuration of sodium, Na plus sodium atom? It becomes 1s2, 2s2, 2p6, 3s2, isn't it? For chlorine, so Na plus ion. And for Cl minus ion, what happens? The configuration, it becomes 1s2, 2s2, 2p6, 3s2, then 3p6. One more electron is accommodated here, so it becomes 3p6. So this is the configuration for Na plus and Cl minus, and it is different from that of Na and Cl. Okay, so we can write the equation for this both sodium and chlorine atom. So sodium, it will be losing one electron, forming Na plus. So Na plus plus 1 electron becomes sodium atom. Again for chlorine, it will be adding 1 electron, then becomes a negative charge. Okay, so Cl minus and Na plus. So here this in this compound, in this ionic compound Na and Cl, see here sodium Na plus, it will be binding, it will be forming a bond with this Cl minus, isn't it? So this electrostatic force of attraction which bounds this sodium Na plus as well as Cl minus together, that is called as the ionic bond or the electrovalent bond. Ionic bond or electrovalent bond. So the force of attraction which holds these two atoms, these two charges, that is the positive as well as the negative charges together, that is called as the ionic bond or the electrovalent bond. So this is the definition for ionic bond or electrovalent bond, that is the positive ions as well as the negative ions, they are held together by a strong electrostatic force of attraction. Okay. And also see here how many electrons are lost from the sodium atom. From sodium it loses 1 electron, isn't it? It loses 1 electron, and also this chlorine atom, it is gaining 1 electron, isn't it? So the number of electrons lost or gained, the number of electrons lost or gained by an atom during the formation of an ionic bond. By an atom during the formation of ionic bond, that is called as the electrovalency. We have seen the term covalency in the previous chapter, isn't it? Similar term is there in the case of ionic bond, and it is electrovalency. That means the number of electrons lost or gained by an atom, that is called as electrovalency. So here, what about the electrovalency of sodium atom? It is plus 1, isn't it? And that of chlorine atom, it is negative 1. So for sodium atom, for sodium, the electrovalency it is plus 1, and for chlorine, the electrovalency is negative 1. Okay. So this is the this is an introduction for this chapter, ionic bonds. Okay. You are familiar with this example, isn't it? You might have studied in your plus 2 classes itself. Next, we can go through the energetics of bond formation or energetics of ionic bond formation. Energetics of ionic bond formation. Energetics of ionic bond formation. See here, this ionic bond formation means this energetics, that means we are dividing this bond formation or the formation of ionic bond into 3 different stages. And these 3 different stages, they are hypothetical. What do you mean by hypothetical? Hypothetical means it is only a theoretical basis, not experimental based. Okay, this is a theoretical one. So this formation of ionic bond, the reaction it can be split into 3 stages. So first step, that is the removal of the electron from sodium atom. The electron, it is removed from the valence shell of sodium atom. So removal of the valence electron from sodium atom. That is the first hypothetical stage. It is just an assumption. Okay. So removal of electron from the sodium atom. See here, from sodium atom 1 electron is removed. Na giving Na plus plus 1 electron. See, for this removal of the electron, see, some amount of energy is required to remove 1 electron from this sodium atom, isn't it? Sodium, this is the first shell, this is the second shell. First shell, it is having 2 electrons, second shell, it is having 1 electron, 8 electrons, and in the third shell it is having 1 electron, isn't it? So for the removal of this 1 electron, this is the valence shell. So for removal of 1 electron from this valence shell, it requires some energy, isn't it? Some energy should be supplied to remove this electron from the valence shell, and this energy used for the removal of this valence electron, or the energy supplied to remove this electron, it is called as the first ionization energy. First ionization energy. So the energy required to remove the valence shell electron from an atom, that is called as the first ionization energy of that particular atom. So here, this for removing 1 electron, the energy required, that is ionization energy, normally we will be denoting it as IE. So the ionization energy required, that is equal to 495.4 kilojoules per mole. Okay, the ionization energy required is this much. So this much energy we have to supply to this sodium atom in order to remove the outermost electron. Okay, then the next one, next hypothetical stage, what is it? It will be the addition of one electron to the valence shell of chlorine atom. Addition of an electron to the valence shell of chlorine atom. To the valence shell of chlorine atom. Okay. Already we had written the equation, that is Cl plus 1 electron. 1 electron is added to chlorine atom. So resulting will be Cl minus ion, isn't it? So here chlorine it is in the gaseous state, Cl minus it is also in the gaseous state. Here also sodium in the gaseous state, Na plus it is also in the gaseous state. So here see, for the addition of one electron to chlorine atom, during this addition of electron to this chlorine atom, some energy will be released. So here some energy will be released. In the previous case, we have to supply some amount of energy, isn't it? In the case of ionization. Here some amount of energy is released during the addition of chlorine atom. So this amount of energy which is released during the addition of an electron to the chlorine atom, that is called as the electron affinity. Electron affinity, or it is the electron gain enthalpy. It is the electron gain enthalpy. Okay. So this is the electron affinity or electron gain enthalpy. Shortly we are writing it as EA. Okay. So ionization energy, then electron affinity. So here for the addition of one electron to chlorine atom, the electron affinity or the amount of energy released will be equal to minus 348.5 kilojoules per mole. Okay. The electron affinity is equal to minus 348.5. Then the next one, the third hypothetical stage, that is the bringing together of Na plus and Cl minus. We have to bring both these ions to closer, isn't it? So closer, so that it will be forming, by combining these Na plus and Cl minus, it will be forming sodium chloride crystal. Okay. So here during this process, by the bringing together of both these ions closer together, what happens is that some energy will be released. Here also some energy will be released during the formation of NaCl. So that particular energy we can write it as the lattice energy. Lattice energy, and is shortly written as U. Okay. So the lattice energy means the energy released during the bringing together of two ions. Okay. So that is the lattice energy. See here in this process, two ions means Na plus and Cl minus will be brought together to form NaCl. So the lattice energy here, U is equal to minus 757.3 kilojoule per mole. Okay. So the lattice energy is equal to negative value. So we can write the overall change. So these are the three hypothetical stages while considering this sodium chloride formation. First is the removal of valence electron from sodium. Second one, bringing together, ionization and electron affinity, that is addition of electron to the valence shell. And the third one, bringing together of Na plus and Cl minus, that is regarding the lattice energy. Then we can write the overall change in this reaction, overall energy change. Overall energy change in this reaction, it will be equal to ionization energy. Then in the second step we have electron affinity, and in the third step we have got lattice energy U. It is not L, it is U. Okay. So the overall energy change will be ionization energy plus electron affinity plus lattice energy, and we can write the values also. See, the ionization energy, the value is 495.4 plus electron affinity, the value is minus 348.5 plus lattice energy U, that is equal to minus 757.3. Okay. So the overall energy change, it will be equal to minus 610.4 kilojoules per mole. You have to calculate the value, and the overall energy change will be minus 610.4. See here, this value, it is having a negative sign, isn't it? Minus 610.4. That means that during the formation of sodium chloride, it means it is accompanied by the process of formation of sodium chloride is accompanied by a decrease in energy. That is what this negative sign indicates. Okay, so the formation of sodium chloride, it is accompanied by a decrease of energy. That is why a negative sign is there. Okay, so here this is the reason. See, the decrease of energy means that particular compound, that ionic compound, is stable, isn't it? During the only a compound will be stable only when the energy component or energy of that particular compound, when it is low only, it is stable. The compound will be stable. Here also the energy change, it is a negative value. That means a decrease of energy is there. So the so formed compound, it is a stable one. Okay. So again we can write three conditions or the three factors which favor the formation of an ionic compound. Okay, factors favoring the formation of an ionic compound. Factors favoring the formation of an ionic compound. So the first factor, that is the low ionization enthalpy of an atom. First factor, that is the low ionization energy or low ionization enthalpy of an atom. And the second one, that is the high electron affinity or the high electron gain enthalpy of an atom. And the third one, that is the high lattice energy. So these are the three conditions which favor the formation of an ionic compound. That means it should have a low ionization energy, high electron affinity, then high lattice energy. Okay. So this is regarding the energetics of ionic bond formation. Then the next one, we can go through the lattice energy. Lattice energy, and is denoted as U. Okay. So how will you define lattice energy? We had already seen while during the formation of NaCl, the energy released, lattice energy, it is the energy released. That is one point you have to take into account. It is the energy released during the formation of an ionic compound, isn't it? So here you can define this lattice energy as the amount of energy released when 1 gram mole of the crystal 1 gram mole of the crystal is formed from its gaseous ions. Okay, so that is what is called as the lattice energy. So this is an important definition, lattice energy, and these factors also very important. Okay, so lattice energy, it is the energy released when 1 gram mole of the crystal. See here, sodium chloride, it is formed from its ions Na plus and Cl minus. Sodium chloride is a crystal, isn't it? So the energy released when 1 gram mole of the crystal is formed from its gaseous ions. Okay. So next is the general representation for this lattice energy. Suppose this gaseous ions we can write in general as A plus and B minus, the anion and the cation. Both of them are in the gaseous state. The two ions to form an ionic compound. A plus B minus, isn't it? So this is an ionic compound, and also in this reaction U, the lattice energy, lattice energy should be a negative value, isn't it? So that the formed compound will be stable. Okay, so there will be a negative energy. And also here, what happens when the positive and the negative ions come closer together, there will be a decrease in energy. This is what this negative sign shows, isn't it? And also see, one more point to see is that the higher the magnitude of the lattice energy, you have to consider the magnitude. Okay, higher the magnitude of lattice energy, comma, greater would be its stability. Greater would be the stability. See, while considering an ionic compound, if the magnitude of the lattice energy, that means this value, the magnitude of lattice energy is high, the stability will also be high. Okay. And also usually for the ionic solids, this the lattice energy. For ionic solids, the lattice energy, it will be usually high. In general, we can say that it is high. And also this high lattice energy, this can be due to the presence of the positive and negatively charged ions, isn't it? These ionic solids, it will be having a positive and negatively charged ions. And also usually the force of attraction, it will be directly proportional to the product of their charges, isn't it? It will be directly proportional to product of their charges, and also this product of the charges, and also it should be proportional to the valency of the ions, isn't it? So two factors are there, the force of attraction, that means the Coulombic force of attraction or the electrostatic force of attraction or the bond formed there. Okay, so the Coulombic force of attraction there, it will be directly proportional to the product of their charges, and also product of their charges, and also if the valency of that charges, it is high, what happens, the lattice energy will also be high. If the valency is high, the lattice energy will also be high. So that means for a single positive charge, for example Na plus, it is an unipositive ion, isn't it? Or it is a univalent ion, isn't it? So it is a univalent ion, so some amount of lattice energy will be there. But in the case of a bivalent ion, what happens, the lattice energy will again be increased. So lattice energy increases from univalent to bivalent, like that. Okay, so the lattice energy, it is proportional to the valency. So or higher the valency of the ion, what happens, the lattice energy will also be high. Okay, so this is one point to be noted. So in our next session, we can go through the Bohn's theory of ionic lattice. So this is regarding the introduction of this ionic compounds and its energetics. Okay, so you have to study this term, lattice energy, the energy released when 1 gram mole of the crystal, it is formed from its gaseous ions. And the 2 points to be noted is that higher the magnitude of lattice energy, greater would be the stability. Usually for ionic solids, lattice energy is very high, and the force of attraction, it is directly proportional to the positive and negative charges, or the anions and the cations present in that particular compound. Then also it is proportional to the higher valency of the ion. So higher the valency, the lattice energy will also be high. And also this lattice energy will increase from univalent to bivalent to trivalent. Okay. So next session, we can go through the Bohn's theory of ionic lattice.